The designer is incorrect. According to Table 210.24, a 50 amp circuit using THHN conductors rated for 90 degrees Celsius requires a number 6 American wire gauge conductor. This table applies to all 50 amp circuits, regardless of the number of outlets. The designer's argument is based on the fact that Table 210.24 includes a note that states this table does not apply to circuits having 2 or more outlets as provided in Section 210.19. A3. However, this note only applies to circuits that have multiple outlets connected in parallel, which is not the case for the range circuit in question. Table 310.16, which the designer cites, provides ampacity ratings for conductors based on their temperature rating and insulation type. However, this table does not provide specific conductor sizes for specific circuit types like Table 210.24 does. Therefore, the correct conductor size for a 50 amp range circuit in Puerto Rico where the National Electrical Code applies is number 6 American wire gauge THHN. To elaborate, let's delve deeper into why the designer's interpretation is flawed and solidify the correct application of the relevant NEC tables. Table 210.24 is specifically designed to provide the minimum conductor size, overcurrent protection, and maximum number of outlets for branch circuits. It's a consolidated reference for common circuit configurations. The table clearly states the requirements for a 50 amp circuit, which mandates a number 6 American wire gauge copper conductor when using THHN insulation. The note regarding Section 210.19. A3 is a crucial point of contention. Section 210.19. A3 addresses circuits with multiple outlets where the load is fastened in place. This exception primarily concerns situations where several devices are connected in parallel and the conductor size must be calculated based on the total load. This exception is not applicable to a dedicated range circuit. A range is considered a single appliance, not multiple outlets connected in parallel. It draws its power from a single point of connection. Table 310.16 lists the ampacity of conductors based on insulation type and temperature rating. It's a valuable resource for determining the maximum current a conductor can safely carry. However, it doesn't supersede the specific requirements outlined in Table 210.24 for common branch circuit configurations. Using Table 310.16 alone to determine the conductor size for a standard range circuit would be incorrect because it doesn't account for the specific requirements outlined for branch circuits. To further clarify, let's consider the hierarchy of the NEC. Chapter 2 of the NEC deals with wiring and protection. Article 210 specifically covers branch circuits. Table 210.24 falls directly within this article and provides specific guidance for branch circuit design. Table 310.16, found in Article 310, addresses conductors for general wiring. While it's essential for determining ampacity, it doesn't override the specific requirements of Article 210 for branch circuits. The designer's reliance on Table 310.16 and misinterpretation of the note in Table 210.24 leads to an undersized conductor, which creates a potential fire hazard. An undersized conductor carrying 50 amps continuously could overheat, damage the insulation, and potentially ignite nearby combustible materials. Therefore, adhering to Table 210.24 and using a number 6 American wire gauge THHN conductor is not just a matter of code compliance but also a matter of safety. In summary, to correctly size the conductor for a 50 amp range circuit, firstly consult Table 210.24 for branch circuit requirements. Secondly, identify the conductor type, in this case THHN. Thirdly, locate the corresponding conductor size for a 50 amp circuit, which is number 6 American wire gauge. Lastly, disregard the note regarding Section 210.19. A3 as it doesn't apply to a dedicated range circuit. To elaborate even further and address potential questions, let's consider the impact of voltage drop. While Table 210.24 specifies the minimum conductor size, it's crucial to also assess the voltage drop across the conductor. Excessive voltage drop can negatively impact the performance of the range. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. If the range is located a significant distance from the electrical panel, a larger conductor size may be necessary to minimize voltage drop. A voltage drop calculation should be performed to determine the appropriate conductor size if the distance is considerable. Now, let's address the specific requirements for dwelling units in Puerto Rico. While the NEC generally applies, local amendments or interpretations may exist. It's always advisable to consult the local electrical inspector or authority having jurisdiction to ensure compliance with any specific requirements in Puerto Rico. However, in the absence of any local amendments, the general NEC requirements prevail. Therefore, Table 210.24 would still be the primary reference for determining the conductor size for a 50 amp range circuit. Let's also consider the potential for using aluminum conductors. While copper is the most common conductor material, aluminum conductors can also be used. However, aluminum conductors have a lower ampacity than copper conductors of the same size. Therefore, if using aluminum conductors, a larger conductor size would be required to achieve the same ampacity as a number 6 American wire gauge copper conductor. Table 310.16 provides ampacity ratings for both copper and aluminum conductors. It is essential to consult this table and select the appropriate aluminum conductor size based on its ampacity rating. In addition to conductor size, it's also crucial to select the correct overcurrent protection device for the circuit. The overcurrent protection device, typically a circuit breaker or fuse, is designed to protect the conductor from overload. The overcurrent protection device should be sized according to the ampacity of the conductor. For a number 6 American wire gauge THHN copper conductor, the maximum overcurrent protection device rating is 55 amps, although it is standard practice to use a 50 amp breaker for a 50 amp circuit. However, it's essential to consult the NEC and local codes to ensure compliance with specific requirements. The choice of wiring method is also important. The wiring method refers to the physical means of installing the conductors, such as conduit, cable, or raceway. The wiring method must be suitable for the environment and application. For example, in areas subject to moisture or corrosion, a corrosion-resistant wiring method should be used. The NEC provides detailed requirements for various wiring methods. It's essential to select a wiring method that complies with the NEC and local codes. Furthermore, it's important to ensure proper grounding of the range and the electrical system. Grounding provides a path for fault current to flow back to the source, which helps to protect against electric shock. The NEC provides detailed requirements for grounding. It's essential to follow these requirements to ensure a safe and effective grounding system. Now, let's delve into some common mistakes to avoid when sizing conductors for range circuits. Firstly, using the wrong table in the NEC is a frequent error. Table 210.24 is the primary reference for branch circuit conductor sizing. Secondly, misinterpreting the notes in the NEC can lead to incorrect conductor sizes. The note regarding section 210.19. A3 does not apply to dedicated range circuits. Thirdly, failing to consider voltage drop can result in poor range performance. A voltage drop calculation should be performed, especially for long circuit runs. Fourthly, neglecting local codes or amendments can lead to non-compliance. Always consult the local electrical inspector or authority having jurisdiction. Fifthly, using the wrong type of conductor or wiring method can compromise safety. Select conductors and wiring methods that comply with the NEC and local codes. Let's address some potential scenarios that might complicate the conductor sizing process. Firstly, if the range has a nameplate rating significantly different from 50 amps, the conductor size must be adjusted accordingly. The conductor ampacity must be at least equal to the nameplate rating of the range. Secondly, if the range is used for commercial purposes, different requirements may apply. Commercial cooking equipment often has higher power demands and requires larger conductors. Thirdly, if the range is part of a larger electrical system with complex load calculations, a qualified electrical engineer should be consulted. Complex load calculations require specialized knowledge and experience. In conclusion, the correct conductor size for a 50 amp range circuit using THHN conductors is number 6 American wire gauge, as per table 210.24 of the NEC. It's crucial to understand the specific requirements for branch circuits and avoid misinterpreting the notes in the NEC. Remember to consider voltage drop, local codes, and the potential for using aluminum conductors. Always prioritize safety and consult with a qualified electrician if you have any doubts or questions. To summarize the key points: 1. Table 210.24 is the primary reference for branch circuit conductor sizing. 2. A number 6 American wire gauge THHN conductor is required for a 50 amp range circuit. 3. The note regarding section 210.19. A3 does not apply to dedicated range circuits. 4. Consider voltage drop, local codes, and aluminum conductors. 5. Prioritize safety and consult with a qualified electrician if needed. Remember that electrical work can be dangerous and should only be performed by qualified individuals. If you are not comfortable working with electricity, always hire a licensed electrician. Improper electrical work can lead to electric shock, fire, and other hazards. Always follow the NEC and local codes to ensure safe and compliant electrical installation. By understanding the principles of conductor sizing and following the NEC requirements, you can ensure a safe and reliable electrical system for your home or business. Furthermore, continuing education and staying up to date with the latest NEC revisions are essential for electrical professionals. The NEC is updated every 3 years, and it's crucial to understand the changes and how they affect electrical installations. Attending training courses and seminars can help you stay informed and improve your skills. In addition to the NEC, various other resources are available to help you learn more about electrical wiring and safety. These resources include textbooks, online courses, and industry publications. Taking advantage of these resources can help you expand your knowledge and become a more competent and confident electrical professional. Finally, remember that electrical safety is everyone's responsibility. By following the NEC requirements, using proper equipment, and taking precautions, you can help prevent electrical accidents and create a safer environment for yourself and others. Electrical safety should always be a top priority. By adhering to these guidelines, you can confidently and safely address the conductor sizing requirements for a 50 amp range circuit and ensure compliance with the National Electrical Code.